Hello, my name is Mark Endo, and I will be presenting our work from MICI 2022 titled GaitForeMer, Self-Supervised Pre-Training of Transformers via Human Motion Forecasting for Few-Shot Gait Impairment Severity Estimation. This is a joint work with researchers from Stanford and SRI International. The task that we are working on is predicting motor impairment severity from videos of gait examinations of Parkinson's disease patients. Briefly, Parkinson's disease is a chronic progressive brain disorder with degenerative effects on mobility and muscle control. One challenge of this task is that we often have small clinical data sets because of the difficulties in recruiting and obtaining data from research participants. However, there are large-scale public 3D motion capture data sets available, and this motion capture data is mainly acquired on healthy subjects using different novel technologies. In this work, we consider how recent advances in machine learning can allow us to take advantage of these resources and translate them for clinical usage. To do this, we use self-supervised learning. So our goal is to learn good representations of raw data using a simple pretext task. Then we can transfer the rich knowledge and use it for an ultimate task of interest, which in this case is the prediction of gait impairment severity, or MDS-UPDRS score estimation. We chose the task of motion forecasting as a general pretext task to learn good and comprehensive representations of motions. In this pretext task, representations of past movements are used to forecast future movements. Based on this, we propose a model named Gait Forecasting and Impairment Estimation Transformer, or GaitForeMer for short, that encodes the past into rich motion representation and then decodes it to future skeletons. In pre-training, the intermediate motion representations are used to predict the activity that the person is doing. And after pre-training, the intermediate motion representations are used to predict the MDS-UPDRS scores on clinical data. Here is a more detailed look of the model architecture. I will not discuss the elements here, but the paper has detailed information about the architecture if you have any questions. For data, we use the NTU RGB plus D to pre-train our model. This dataset includes around 57,000 video samples with 60 action classes. The skeletal data contains 3D coordinates of 25 joints. For the downstream task of gait impairment severity estimation, we use a previously collected MDS-UPDRS dataset. This dataset contains exams from 54 participants, and we are predicting one part of the examination, where specialists assess the severity of motor impairment on a score from 0 to 4. Using the gait recordings as input, we use Vibe to extract the 3D skeletons. In our results, we find that our GaitForeMer method pre-trained on a public dataset results in improved accuracy over training the model from scratch and other baselines trained on the MDS-UPDRS dataset. This pre-trained method has a statistically significant improvement in performance over the previous state of the art on this task. We also showed that if we train our model with even fewer data than we have, we still obtain strong results. So we sample either 25%, 50%, or 75% of the data. And we find that our GaitForeMer method maintains relatively strong performance with only a fraction of the data. For example, with access to 25% of training data, it achieves an F1 score of 0.56, which is higher than the STGCM baseline using 100% of training data, and is even comparable to the previous state of the art using 100% of training data. This shows the power of using motion forecasting as a self-supervised pre-training task for few-shot gait impairment severity estimation. We can also look qualitatively at the motion forecasting outputs of our GaitForeMer model. The purple skeletons are ground truth data, and the blue ones are predictions from GaitForeMer. These results verify that the forecasting module is able to properly predict future motion that encodes motor impairments. In conclusion, we found that human motion forecasting serves as an effective pre-training task to learn useful motion features that can subsequently be applied to the task of motor impairment severity estimation, even in few-shot settings. The pre-trained GaitForeMer model outperformed training from scratch and other methods for motor impairment severity estimation that solely use the MDS-UPDRS dataset for training. And our approach demonstrates the utility of using motion pre-training tasks in data-limited settings. Thank you for listening.